Okay, so here we have a delicious related rates problem involving molten chocolate, which reminds me of put on some weight recently. But so yes, it's a bit of an intermediate problem, I would say, and I'm gonna be assuming that you're comfortable with implicit differentiation, especially, and I'm also gonna assume that you've read the problem. If you haven't, I would suggest that you pause it, you pause the video, and you read it for your own benefit, of course. So, okay, so we have chocolate being poured into a container shaped like a cone. So here we're gonna make good use of just similar triangles because we have this little triangle right here, and this is gonna be just basically the chocolate right there, and I'm gonna call this little height h and the little radius r. Okay. So these measures are really important. The measures of the big container cone. And here we have another triangle. I'm actually just going to draw in a different color. We have this big triangle here, and that was not a different color. We have this big triangle here. Whoops. And this little triangle here. And using similar triangles, we can establish a relationship between the radius and the height, which would be very useful in this case. So the radius is to the height. The radius is to the height. Like 16 inches is to 24 inches. So r is to h, like 16 is to 24. And of course, just a small detail, it's a diameter of 32 inches. So obviously, we can just divide that by 2 to get the radius. So fantastic. Let me just reduce this fraction here. So divide top and bottom by 8 and get 2 over 3. Then I shall cross multiply and get r times 3. So 3r is equal to 2 times h, 2h. Great. Now, what do we want to do? We're looking for, I'm going to leave this for now, by the way, and just take a look at what we're looking for here. We're looking at what rate the chocolate is being poured into the container. In other words, we're looking for the rate in which the volume is increasing. So dV dt is what we're looking for. And what do we have? We have the circular surface of molten chocolate has a radius of 2 inches, so we know that little r is 2, while the radius is coincidentally increasing at a rate of 2 inches per second, which means the r dt is 2. Wow, that was the ugliest r I have ever drawn or written. So dr dt is equal to 2. Great. So now coming back here, I want to make a decision because I don't want both r and h in my formula here. I want either or. Because we have dr dt, my choice will be to eliminate the h. Okay? So what I'll do is that I will isolate the h by dividing both sides by 2 over here. So I get 3 r over 2 is equal to h. Just divide both sides by 2. So, and I'll take this and I'll plug it in for h right here. So I get v equals 1/3 pi r squared times 3 over 2 r. Fantastic. Now, let's simplify the volume expression. So the 3's cancel out. You can multiply the r, so get v equals pi r cubed over 2. So that is the volume of the chocolate as a function of the radius of the little circle surface there, the circular surface. Great. Now what do we do? What do we do? Now we differentiate both sides with respect to t. So we get d dt of v and d dt of pi r cubed over 2. Fantastic. Now I'm just going to remove the constant from the derivative here. So get pi over 2, then d dt of r cubed. And d dt of r cubed, I can just take the derivative of r cubed, which is with respect to r, right? So I get 3r squared, and multiply this by dr dt. Because that's basically how implicit differentiation works. And if you can't remember how it works, you can just visit our website and check it out. Over here, d dt of v is just dv dt. Fantastic. Now we have all elements we need in order to solve the problem. We have r, we have dr dt, and then we can find dv. Great. So dv dt is equal to pi over 2 times 3 r squared. R is just 2, so 2 squared, times dr dt, which is also 2. Look at that. So get pi over 2 times 3. 2 squared is 4. 4 times 2. Actually, I'll just leave the 2 there because it can cancel out with this 2. Look at that. And I just get 3 times 4, 12 pi. And we're done. But what is the answer to the question? And what rate is the chocolate being poured into the container? We're dealing with volume, right? And we're dealing with inches. So we want to say 12 pi cubic inches. So cubic, I guess inches cubed, or cubic inches per, is it seconds? Per second, yes. So 12 pi cubic inches per second. That's it. We're done our delicious related rates problem.